Some quick examples on how to find polar coordinates for rectangular coordinates. So I want to change -4, 5 into something in terms of r and theta. So polar coordinates are generally set up as r theta, where r is the radius and theta is the angle of revolution. Alright, so first things first, I would plot -4, 5 approximately where it goes. So -4 to the left, 5 up, it's someplace up here. And we can draw a line to it from the origin. We could draw a line to it from the origin, and that would be the radius of this polar coordinate. And then to figure out everything, I would highly suggest doing a little right triangle trigonometry to figure out radius and the angle. Now theta in this case is going to be this angle here, the wider opening. So we're going to work with the reference angle, which is in here. Label the sides. This side is -4, this side is 5. To find the radius, it's just a simple Pythagorean theorem. 4 squared plus 5 squared, which would be 25, plus 16, which is 41. So this side would be the square root of 41. Well, that's what r is equal to. And then to find theta, we're just going to do a little tan inverse. So tan inverse of the ratio opposite over adjacent, it'll be -5/4, and that should give us the measure of the angle except for one problem. Tan inverse only works in the first and the fourth quadrant. So when we do this answer, tangent in the second quadrant is negative, so the calculator is going to give us this angle in the fourth quadrant. I just have to take that reference angle and apply it to the second quadrant. So tan inverse of -5/4 is -51 degrees. Obviously that's down here, but that makes the reference angle 51 degrees. So if I take that away from 180, that gives me 128.7. So for r theta, this is 128.7 degrees. R theta in this case will be r, square roots of 41, and theta would be the 128.7 degrees. And this would be the exact same location on a piece of graph paper as -4, 5. Let's try it for this angle, -7, -9. Well, -7, -9 is someplace down here in the third quadrant. If I draw a line from the origin to that point, that'll give me my terminal side of my angle. It also gives me my radius for my polar coordinate. So again, we're going to set up a right triangle, label the sides appropriately. This side is -7, this side is -9, and this side will be the square root of 130, which doesn't break down sadly. So square root of 130, and radius, remember, are always positive, so don't be changing that. So the r part of it is square root of 130. The next piece is we need to find this theta. So again, we're going to set up tan inverse of my ratio opposite over adjacent, so it'll be -9 over -7, which is +9/7. Do tangent inverse of 9/7, and we'll get 52.1 degrees. But 52.1 degrees is in the first quadrant. We want our angle to be in the third quadrant. So to get there, we're going to have to make this the reference of 52.1 degrees and add 180 to it. So we'll end up with 232.1. So theta, this angle, is 232.1 degrees. So the r theta here will be square root of 130, comma 232.1 degrees.